Okay, guys, so let's go ahead and solve this example. It says, a dean wants to check the consistency of teaching quality among the faculty in one of the departments. A sample of students was obtained from 5 classes taught by 5 different faculty, and their common final exam scores were recorded. So we have 5 different classes, and because we're comparing samples from different populations, so we're gonna select an ANOVA procedure. So here, can you conclude that the teaching quality is inconsistent among the courses? Use the level of significance 5%. So which procedure we're using? We're using ANOVA procedure. Now, assumptions. Remember, for the ANOVA procedures, we need equal population standard deviations. We need normal populations, independent samples, and simple random samples. Okay, let's see if we have all of that. It says a sample of students was obtained from 5 classes. Um, okay. Actually, there is nothing in the problem tells us that this samples was simple random, and the samples, well, the samples were independent because these class members are not connected to each other in any way, so the samples are independent. It doesn't say that they're simple random. But those are the assumptions that we need in order for ANOVA procedure to work. So we're gonna mark, I guess it's just assumed that all of those are applied. Okay, so let's continue. What the hypothesis, the null hypothesis. The null hypothesis is always the same for ANOVA test. It's all the means are equal, and the alternative is that not all the means are equal. And the test is always right-tailed. Now, the next step 2 is to figure out the significance level alpha, and they told us that significance level is 5%. So we are gonna put 0.05. Oh, actually, I'm sorry, they want us to enter percentage because there is a percent sign there. So it's 5. Enter integer or decimal number. Okay, 5%. Step 3, with a total number of observations. So basically, we need to figure out the total number of observations. N. Let's see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 in the first one, 5 in the second, 9 again in the third, 8 and 6. So the total number of observations is 37. Now, for number of populations, we have 5 different classes, so that's k equals 5. All right, then let's continue. This is something that we need in order to use our F distribution. For the F distribution, the degree of freedom for the numerator, we're going to have k minus 1, so k is 5, k minus 1 is 4. And for the degree of freedom of the denominator right here, that's n minus k, so that's going to be 37 minus 5, it's going to be 32. All right, we need those numbers in order to look up our critical value. All right, so the next is the test statistic. All right, so at this point, we need to use our StatcCrunch to calculate our test statistic and the critical value and the p-value. So I'm going to show you how to copy this table into the StatcCrunch. All right, so what I'm going to do first, what we need to do, we need to highlight the data we want to copy and copy it. In PC, it's Control V, and then we're gonna go to open Excel spreadsheet. So here's my spreadsheet. I'm gonna click on a cell, and for paste, I'm gonna choose paste special, and I'm gonna choose text. All right, here you go. You actually have to go through this process, otherwise you're not gonna get the results you need, the formatting you need. Okay, so now we're gonna copy this table again, because now it's in a different format than the table in your homework assignment. Then we're gonna click on a different cell and again go to paste special, and we're gonna select transpose. Okay, so here's my data now, and now I'm ready to transfer it into StatcCrunch. I am going to select one column, copy, and paste it into StatcCrunch. I could actually do the whole thing, but I would, and by the way, before we go back, I will call it class 1, this column. I'm going to do it for every column. I could copy and paste the whole table, but I would have to get rid of these columns first because I would get blank ones in StatcCrunch. So here I finished transferring all my data from the problem into StatcCrunch. Now it looks like this. So that's a little bit of a twisted way to get there, but you can actually type everything by hand if you choose to, but the possibility of making a mistake is too high. So I like to do that, just copy and paste several times. Now, the test statistic. All right, we need to round to 3 decimal places. What we're gonna do, we're gonna go to Stat, select ANOVA, one way, and select our columns. So we're gonna hold Control on PC, and we're gonna, or Command on Mac, and select all of our classes and hit compute. So this is what we got. Okay, we have our statistics, the mean for each class, the standard deviation for each class, the standard error for each class. And here's the statistic that we need. We need 0.4150159. So this is our computed value. Now for the p-value, this is it right here, 0.7965. So let's put those in to our problem. So the test statistic here is 0.415, round to 3 decimal places with the degree of freedom. So that's what we have. The degree of freedom of the numerator is this value right here. That's a 4. And the degree of freedom of the denominator is this value here. That's a 32. Now, why do we need those values now? We need them to find our critical value. But before we get to the critical values, let's fill in the p-value because we already have it right here. That's a 0.79, and they want us to decimal number with decimal places, 3 decimal places. So 7 would be the last digit. We round up because of the 5 after the 6. Okay, so let's go ahead and talk about how to find our critical values. Now, remember that the significance level is 5%, right? And the degree of freedom numerator is 4. Degree of freedom of denominator is 32. All right. So we're gonna go to calculators, F distribution, degree of freedom of a numerator was 4, denominator is 32. All right, and the area in, first of all, it's a right tail test, and the area in the right tail was 5%. There we go. So that value is, the critical value is 2.668. Let's see how many decimal places we need. Okay, integer 3 decimal places. All right, so okay, let's be careful because it says left critical value. So we don't have, it's since it's a right tail test, we have a critical value on the right, which is 2.668. And on this one, we're going to put DNE, which means does not exist. Okay, so that's step number 4 of our process. All right, so let's continue with this test. The next step 5, decision. Is a test statistic in the rejection region? Well, what was our test statistic? Our test statistic is right here, 0.415. Where's 0.415? It's about right here. Our critical value, our rejection region is this, the red one. So our p-value is here. I mean, computed value is here. So Is the test statistic in the rejection region? The answer is no. Is the p-value less than the significance level? So the p-value is 0.797, and the significance level was 5%, so 0.05 right here. Is it less? The answer is no. So what is our conclusion gonna be? Well, we do not reject the null hypothesis because of both of these. Step 6, interpretation. At 5% significance level, we do not have sufficient evidence to reject the null hypothesis in favor of the alternative hypotheses. All right, so this, guys, this is it. So let's submit. All right, so we got all of these questions correct. So this is it, guys. This is how you use StatcCrunch to do the ANOVA, one-way ANOVA hypothesis test. So again, as a reminder, these are the steps. Well, first we're gonna check all the requirements, and then your null is that all means are equal. Your alternative says not all means are equal. Then it's always a right tail test. Alpha is going to be given to you. The test statistic, you're going to use StatcCrunch to calculate the test statistic and the p-value, and then you're going to use the F distribution to calculate the critical value. Remember, there is no critical value on the left. Your critical value is going to be on the right because it's a right tail test. Now, when you're calculating your critical value, for the degree of freedom of the numerator, you're going to put in k minus 1, where k is the number of samples, and the degree of freedom of the denominator, it equals n minus k, where n is the total number of observations and k is again the number of categories. So once you're done that, then you're gonna look at critical value versus the test statistic, or the p-value versus alpha. Make your decision and interpret your results. Let me know if you have any questions, and I'll see you in the next class or the next video.